Welcome. Today we'll solve a challenging implicit differentiation problem step by step. Let's look at our equation. We need to find dy dx for this equation. Since y is implicitly defined in terms of x, we'll need to use implicit differentiation. Let's differentiate both sides with respect to x. On the left side, we'll use the product rule since we have a product of x and cosine y. On the right side, we'll use the chain rule since we have a composite function. Now, let's handle the derivative of cosine y. When we differentiate cosine y with respect to x, we get negative sine y times dy dx, and the derivative of x plus y is 1 plus dy dx. Putting it all together, we get cosine y minus x sine y dy dx equals cosine of x plus y times 1 plus dy dx. Let's distribute on the right side. This gives us cosine y minus x sine y dy dx equals cosine of x plus y plus cosine of x plus y dy dx. Now let's get all terms with dy dx on one side and all other terms on the other side. Moving everything with dy dx to the left side, we get negative x sine y dy dx minus cosine of x plus y dy dx equals cosine of x plus y minus cosine y. Finally, we can solve for dy dx. Dividing both sides by the negative coefficient of dy dx, we get our final answer. Dy dx equals cosine y minus cosine of x plus y, all divided by x sine y plus cosine of x plus y. And there we have it. We've successfully found dy dx using implicit differentiation. The key steps were using the product rule and chain rule correctly, and carefully keeping track of all our terms with dy dx.